Hi, in this video, we're going to examine the issues with a single area OSPF in large routing domains. Really a precursor to why we want to go with multi-area OSPF in larger routing domains. So as you remember, whenever there's a change in the topology, whenever an OSPF router learns any kind of new information, it adds that information to its link state database, runs the shortest path first algorithm, calculates a SPF tree, shortest path first tree, and then offers the best paths to the routing table. And in a single area OSPF, these routers will have to do it for any changes, any new information within the entire OSPF routing domain. So here we have a single area OSPF. In single area OSPF, we have all the routers are in a single area, of course, known as area 0. It doesn't have to be area 0, but area 0 is the best practice for a single area. Now here we have what, 3, 4, 5, 6, 7 routers in the OSPF routing domain. Not a very large routing domain, and a single area would be fine. But try and imagine we have dozens, even hundreds of routers in this routing domain. Okay. Area 0, by the way, is also called the backbone area. And again, it is useful in smaller networks, but with just a few routers. But what if this was a much larger routing domain? Okay, so one of the issues that routers will have is very large routing tables. OSPF does not automatically summarize routes. There is manual summarization that we'll be taking a look at in later videos, but also some automatic summarization that happens, well, not really summarization, but some other ways we can reduce the routing table size with something called stub and totally stubby areas. I'll be talking about that in a later video as well. But anyway, large routing tables, that can become an issue. Remember, we want to keep routing tables as small as possible. Smaller the routing tables, faster the lookup, less memory required. Also, with large OSPF routing domains, we can have routers, OSPF routers, with very large link state databases. And this can cause issues when having to do any kind of recalculations, having to recalculate the SPF tree for all the link states in the link state database, which also increases the load on the CPU, requires more memory, etc. And also, frequent SPF calculations. Well, frequent in terms that any change in the topology, any change in this routing domain is going to cause all the routers in the routing domain to recalculate the SPF algorithm. Okay. And if we had like a flapping link someplace or a network that was coming up occasionally or going down occasionally, or changes being made, it would mean all the routers, could be dozens, hundreds of routers in this routing domain having to recalculate the SPF algorithm. Okay, so we're going to look at solutions to all of this in later videos. And all of these solutions, of course, are going to be centered around multi-area OSPF. So multi-area OSPF is a hierarchical routing architecture, which allows you to separate your routing domain into smaller subnet. Well, I don't want to use term smaller subnetworks, maybe smaller internetworks, as I have there, that are called areas. Okay, so routing still occurs within the routing domain. It just occurs between the areas, which we call inter-area routing. Okay. And we're going to see that some operations are restricted within an area, such as the flooding of certain LSAs that require the rerunning of the SPF algorithm. So as we're going to see here, that it actually can help reduce the number of routers that may have to run the SPF algorithm when there's a change. Okay. So Multi-area OSPF uses a two-layer hierarchy. It uses a backbone area, area 0, which is used to then interconnect all the regular areas. Okay. So the regular areas, here I have area 0 as our backbone area, which area 0 is always the backbone area. Then we have area 1 and area 51. And these would be typically where we have our users connected and our servers and everything else. And we'll talk more about the architecture of this a little later. But some of the advantages of multiple areas, first of all, smaller routing tables. Okay, and this is particularly the case with something we're going to talk about later with stub and totally stubby areas. Okay, so this is going to mean that the ability to either use stub and totally stubby, as I mentioned, or to do manual summarization to summarize routes between the areas. Okay. Also, reduce the link state update overhead. So having fewer LSAs, smaller link state database, less memory, faster SPF calculations. And we're going to see that we're going to have different types of LSAs. I'm going to go into this a lot more detail in a later video. I'm going to talk about OSPF link state advertisements and how they relate to different areas. And you're going to see the advantages of this coming up shortly. Okay. And one of the big advantages of doing this is reducing the frequency of the SPF calculations. So if there's a change in, say, area 51, only those routers in area 51 have to actually rerun the SPF routing, SPF algorithm. Now, the routers in the other areas, area 0 and area 1, will find out about the change, but they don't actually have to rerun the SPF algorithm. You may wonder why. Well, only the routers in area 51 rerun the SPF algorithm because they're the only ones that actually have a map, a topology map of that area. So routers within an area only have a topology map within their area. They can know about networks in other areas, but they don't have a map of the other areas. We're going to talk more about that a little later. Okay. So that's just the issues with single area OSPF and large routing domains. A lot more to come.